In air conditioner, we have to check for the symptom of less cooling. We are going to cover the feedback from the customer, questions to be asked for the customer, dot matrix, related to the symptoms, possible type of failures, electrical, electronics, mechanical usage in environment, steps for diagnosis process of steps, repairing of those defects. Customer feedback is of less cooling. So the questions to ask the customers, what is the set temperature on the air conditioner to understand the compressor running time? What is the selected mode on remote to check proper cool mode is selected or not? How many appliances like heat generating appliances like refrigerators, desktops, bulbs, other heat sources and room occupants etc. in the room to understand the heat load in the room. What is the capacity of your room air conditioner? 1 ton, 1.5 or 2 ton so that heat load matches according to the AC tonnage capacity or not. Observe and ask the size of the room, window, glass and walls etc. so that the heat load matches according to the AC tonnage capacity or not. Have to check the cleaning of the air filter to verify the air filters are clean and the cool air is flowing without restrictions. Ask about the last service done to check any choke conditions inside the air conditioners. Observe and ask the location of the room like ground floor or the top to understand the heat load of the room. Observe about any error code is there on the display to understand any component is not malfunctioning. Ask about any previous repair done so that clarify is there any workmanship issues done previously. Dot matrix for the defects like incorrect voltage, incorrect mode selection, in case of remote control, wet and dry service not done, filters and coil block, frequent door opening and entry of the hot airs, improper installations, outdoor unit and indoor unit position, air short cycle or air circulation problem, IDU, short cycling of hot air around the ODU, IDU blower motor problem, IDU PCB, room temperature sensor defective, outdoor unit capacitor issue, outdoor unit fan motors issue, gas leak partially, compressor tripping or OLP failure, poor pumping, defect due to pinching of connecting pipes, or more heat load and AC is under capacity. Now we talk about the possibility of the failures. The incorrect voltage, capacitor, fan motor ODUs and OLP is an electrical type of defect. Defect in indoor PCB or room sensor is an electronic type of defect. Compressor gas partially leak, pinching of the connecting pipe is a mechanical type of defect. Improper mode of selection, entry of hot air is a usage issue. And PM service and ambient temperature high is an environmental situations. Parameters to be checked. To check the incorrect voltage, we have to suggest a customer for correct stabilizer. The selection of the wrong mode on the remote. We have to set the cooling mode. Then we have to check for the wet and dry service not done on the filter coil block. We have to ensure the proper service operation and then check the frequency of door opening and entry of the hot air. Educate the customer about uh, and plug the gaps. Location of the IDU mounted. We have to check it is on the southwest wall, and in case there's an issue, we have to change the IDU location. Other walls and the roofs of the rooms are insulated. Insulation of the walls to prevent the direct heat entry. We have to check the indoor blower motor. In case there's a problem in the blower motor, we have to replace it. Then we go for indoor PCB defective, indoor PCB if it's okay, then we have to go for the next step. In case there's a problem with the indoor PCB, you have to replace it. Then location of an outdoor unit mounted. It should be at ventilated area, and we have, in case the outdoor unit is mounted at an area where the ventilation is not proper, then we have to change the outdoor location in shaded area. Outdoor fan motor, we have to check it's working, and if it is not working, we have to replace the outdoor fan motor. Check for the capacitor ODU defective. Capacitor is okay, then if there is a problem with the capacitor, we have to replace the capacitor. Then check the OLP or compressor defective for poor pumping. If there is a problem with the compressor, we have to replace the compressor. Then connecting the check for the connecting pipe. If there is any pinching, if we have to repair or replace the pipe. Then we check for the gas pressure. If there is a partial gas leakage, we have to trace the leakage and then refill the refrigerant again. Check for electrical socket. The voltage between the neutral and phase is 230 volt. Voltage between phase and earth is 230 volt. And the voltage across neutral and earth should be between 0 to 2 volt. If the input voltage is low, suggest the below mentioned stabilizer to the customer. In case of a defect due to selection of the wrong mode on remote, we have to check the selected mode on the remote and guide the customer for cooling. They should select the cool mode. We have to press this mode button to select the cool mode. You check for the wet and dry service not proper. In that, you have to check the condition of the cooling coil and the condenser for blockage. If required, we have to remove the indoor unit for wet service. We have to check the parameters like grill and return air temperature. If the grill temperature is 12 and adding 10 to grill temperature, it becomes 22, which means the suction air temperature. If grill temperature drops 10 degrees within 5 to 10 minutes of working, it shows that the AC is working okay on medium fan speed RDU unit. We have to clean the air filter for dry service. Check the IDU blower for any blockage. Recheck the parameters like grill and return air temperature. We have to do the wet service with the help of jacket and pressure pump. Recheck the parameters like grill and return air's temperature. In case of frequently door opening and entry of the hot air, we have to check the gap between the doors and floors, air leakage through windows, heats transfers through window glasses. We have to plug the air gas with the help of a foam tape or insulation tape. We have to educate the customer about the addition of heat load due to sunlight or frequent door opening. If the defect is related to IDU, ODU installations location, we have to check the location of the IDU, indoor unit, and outdoor unit. Condensing side of the ODU must not be in the southwest direction. ODU should be in the ventilated area, preferably in the shade. In case of reinstallation of IDU and ODU, we have to install the unit in a ventilated area with no blockage of air. Install the unit on rigid wall to absorb the vibration. We have to install the unit in the center of the wall for uniform circulation of air. Install the unit away from the source of heat. Install the unit in the area where connecting copper pipe is easy. We have to install the unit in an area which is not exposed to the direct sunlight. We have to install the unit in the areas with good ventilation. We have to install in the areas which is free from animals, plants and obstructions. We have to install the unit in the areas which does not amplify the sound. We have to install the unit in the area with easy access to service. We check the indoor blower motor or bush jam. Check the working of the indoor blower motor. Check the left hand side bearing or bush for the free rotation. Rotate the blower with hands to check the working of left hand side bush. If blower is moving, then bush is also. Confirm the operating voltage of the indoor motor, AC or DC. We have to check the resistance in indoor blower motor in between brown and red wire, between white and red, and between brown and white wire. The voltage across brown and white wire is 83.5 volt AC. Voltage across 1 and 3 terminals is 5 volt DC. We have to rotate the blower with the hand to check the working of left hand side bush. If blower is moving, then the bush is okay. Confirm the operating voltage of the indoor motor, AC or voltage across terminal 1 DC plus and 3 ground terminal is in between 310 to 350 volt DC. Indoor PCB defective, we have to check the resistance value of the sensor with respect to the change in the temperature. We have to check the voltage at room temperature jacket and check the PCB relay. We'll check the resistance as per the temperature and the above reading is at 34 and 90 degree centigrade. Now we will test the supply voltage for room temperature sensor and coil temperature sensor from the PCB. 5 volt DC is available from the PCB to the sensors. PCB is working fine. There are defective capacitors. The defect related to the capacitors are capacitor may be open, short, leaky, burned or swollen. We have to select the multimeter on high resistance value in mega ohms. Connect the wires with the capacitor. The capacitor when tested on resistance scales, it slowly increases its resistance and then tends to infinite or over limit. Select the multimeter on capacitance. Connect the wires with the capacitor. When capacitor tested on capacitance scale, it must show its values written on it in farad plus minus 5%. In case of outdoor fan motor, before checking the motor, we have to ensure that the capacitor is okay. Check the motor as per the operating voltage AC or DC. We have to check for operating voltage of outdoor unit, motor AC or DC. The instruments required is multimeter, power cord and capacitors. We have to check resistance to identify C, S and R windings. Identification of CSR windings. Values may change with the change of the AC voltage. We check the values between orange wire. Then we check the values between orange and blue wire. Values may change with the change in the AC model. We have to find the windings because the maximum value of 598 ohms is in between blue and orange wire, and one of them is running, another one is starting winding. Hence the black wire is common. With respect to common black wire, orange wire have lesser values, 284 ohms to, so orange wire is a running winding. With respect to the common black wire, blue wires have higher values, 330 ohm, so blue wire is a starting winding. We have to supply voltage to AC motor, phase given to the common wire and the neutral given to the start wire. In case of DC motor, we have to confirm the operating voltage of outdoor unit. Motor is DC. We have to check the voltage at PCB, the VSP and ground, the speed control voltage input is black and yellow wires, which will be in the range of 0 to 6 volt DC. VCC and ground at white and black wire, the voltage is 9 to 10 volt DC. At VM and ground, red and black wire terminals, the voltage will be 0 to 390 volt DC. We check for gas leakage. We have to check for the respective refrigerant pressure. In case of complete gas leakage, we have to check the back pressure. Indicates that there is no gas in the seal system. In this case, we have to first identify the leakage, repair the leakage and place the parts. Refill the refrigerant by weighing method only. Required tools is manifold gauge, digital climameter, digital temperature meter, electronic heat detector, refrigerants, vacuum pump 2-stage 5 CFM, micrometer, charging hose, weight machine, single gauge, nitrogen cylinder with regulator, and a soap and sponge. Have we have to identify the location of the leakage. Then we have charged the nitrogen for leak testing, release the balanced refrigerant from the system, if any, charge 100 psi oxygen-free dry nitrogen in the seal system, increase the pressure gradually to 200 psi if the leakage is not found at 100 psi. In order to find the leakage, there are two methods which have been used. One is soap solution, another one is electronic leak detector. In case if leakage is not found, separate the indoor unit and the outdoor unit in connecting pipe and carry out a least we have to hold the nitrogen pressure up to 300 psi for at least for 2 hours. If there is a drop in the pressure, we have to check for the leakage again and adopt the same procedure. Once leak free is confirmed, we have to release the nitrogen from the system. Now we'll do the vacuum by using 2-stage 5 CFM vacuum pump. We evacuate the system at least for 1 hour. Instead of checking for 1 hour, it is always recommended to use micron gauge and vacuum the systems up to 1000 microns. You have to keep the valve on the refrigerant can closed. Open the valve A and valve B of the manifold gauge. We start the vacuum pump and check the reading on the micrometer. Once the micrometer readings comes out down to 1000, close valve A and close valve B for manifold gauges. Stop the vacuum pump. Seal system evacuation is complete. We have to charge the system now. For that, we have to press a tiller button on the weighing meter to set the meter as 0. Then we have to open the valve of the refrigerant can slowly. Open the valve A of the manifold gauge slowly, keeping the valve B closed. Refrigerant will automatically flows into the seal system. We have to check the weight of the refrigerant charge. We have to connect a new cane once the first cane is fully charged to the seal system. Close the valve A and the valve on the refrigerant cane once the required amount of refrigerant being charged to the seal system. Now we check the performance of an air conditioner. We observe the system parameters like ampere, temperature and pressure after testing and commissioning of the machine. We check the pressure and the operating pressure as per the below chart. Then we check the temperature. Difference in the inlet and outlet temperature should be 10 to 12 degree after 15 to 20 minutes of running. The gill temperature will become 10 to 12 degree after 20 to 30 minutes of running. Then we check the ampere. Ampere reading should be as mentioned in the machine sticker. Check for the low pumping. With that, we have to check the ampere reading during the compressor running condition. It should be in the range of nominal ampere, which is mentioned on the compressor sticker in goods condition. In low temperature case, it shows lower values than the above range. Check the suction pressure. In case of low pumping issues in it, it will be above normal suction pressure. If the compressor is found to have a low pumping issues, we have to replace the compressor with a new one. We have to ensure that we have to replace the compressor with the same model compressor only. We check for the pinching of the connecting pipe. We have to replace the entire connecting pipe if possible, or cutting the pinched areas and brace a new pipe in the area. After bracing, we have to check for any leakages, and leak free is confirmed. We have to charge the refrigerant back into the system. Thank you.